Hello everyone. In this video, I'm gonna briefly talk about the comprehensive examples that you can find in the notes for chapter 4 on page 7. Let's get started. In the first question, we're asked for the APR and EAR for the loan arrangement. So let me briefly talk about what is payday lender. It's a special type of loan arrangement. For example, if you're expecting your paycheck in 10 days, but right now you really need money to pay for the rent, what you can do is go to the payday lender and borrow money from them, and then you're gonna pay them back on the payday. Okay, so in order to calculate APR and EAR, here's the formula. APR is basically the simple interest for a year that equals to the interest rate per period times number of periods. And EAR is like the compounded interest rate for a year. So we're considering the compounding here. Now this R interest rate per period also equals to interest rate per year divided by number of periods. Okay. So in order to calculate those two values, the only thing we need to know really are the R and M. Okay, so the first question we need to think about is, what is the length of a period? Obviously, it's 8 days because during this 8 days, this transaction completed. Over this 8 days, we know that the PV equals to 500 and the future value equals to $626. Once we know those two, we can calculate the interest rate over this 8 days, which is R. Okay, so over any period, the PV times 1 plus the interest rate should equal to give us the future value. Okay, so to solve for the R, you can use some algebra to get it, but of course we can also use financial calculator, okay, because this is a time value of money question. So this n is 1, right? So this happened in 1 period, so n is 1. I over y we need to calculate it. Present value is $500. Payment is 0, okay, because we only have 2 cash flows. And the future value equals to $606.37. Now remember, in the last lecture, I told you that whenever you input PV and future value at the same time, one of them has to be negative. So I'll set the future value to be negative. Okay, and then we compute I over y. So I over y is 25.274%. So the second thing we want to know is M. How many periods are there? So over a year, there are 365 days, and each period is 8 days. So we use the 365 divided by 8. That gives us 45.625 periods. Okay, so now we can plug in all the numbers to find the APR and EAR. So APR would simply equal to this number. Okay, you can do this, use just simple calculator. Now EAR will equal to 1 plus the R to the power of m minus 1. Okay, now to get this number, there are 2 methods. One is that you can use the power function just to solve the problem using a simple calculator, and the second one is to use the interest rate conversion formula that we talked about in the last class. Okay, I'll show you both. Let me clear everything. Okay. So to use the power function, we can use the y to the power of x function. So we're gonna first input the y, which is the number within the parentheses. So 1 plus 25.274 and percent and equal. Okay, so this is the value within this parenthesis, and then y over y to the power of 45.274 625 and equal, and then minus 1. Okay, so this is the number. Okay, now we need to convert it back to the percent. In order to convert back to percent, we simply multiply it by 100. Okay, it's like 1 would equal to 100%. So you multiply that number by 100 and add the percent sign. Okay, so this is exactly what we have here. Okay, so I eliminated so I rounded up to the nearest integer. The second method is to use the I conversion. Okay, so I'll go second 2. If you look at the number 2 on top of it, it's ICONV. That stands for interest rate conversion. Okay, that's what we're going to use. To trigger this, we're going to go second and 2. And the nominal, so the first parameter is NOM, which stands for nominal, which is the other name for APR. Okay, so the nominal is APR. If you go down, you can see EFF, that's effective annual rate. Okay, and you further go down, C over Y is the compounding frequency per year, which is our M. Okay, so the way you use this is the same logic as the normal time value of money type of question. You input everything you know and compute for the other parameter you don't know. So let me go back. Nominal interest rate, it's something we know. Okay, 1153.12. 625. I'm keeping a lot of decimals just to be more accurate. And then you're gonna hit enter. Okay, after hit enter, you can see the equal sign. If you don't do that, you don't see the equal sign. Okay, make sure you hit enter. Now so remember here, we don't need to add the percent sign. Okay, the financial calculator adds it automatically, so we don't need to convert it. We go down, effective annual rate, we don't know yet. Okay, we go down. Compounding frequency is 45.625. Again, there's no equal sign. Then what you do is enter. Okay, and now we're gonna either go down or go up until we reach the effective annual rate. Okay, you can go down twice or you go up. Okay, it's the same thing. So, and then we just hit compute. So this is again exactly the number we have in here. Okay. Now remember, you might find this number to be a little bit different from the one you can see on the full version notes, because there I'm not keeping the 5 digits of the decimals, so the numbers will be a little bit different just because of the rounding issue. Okay, now the second question, you can pause and read the question now. Now, it's asking us how much, in the third year, how much interest would you earn? And also, within that interest that you earned, how much of it is simple interest and how much of it is compounding of interest? Remember that here we're asking for the interest you earned only in the third year, not over the 3 years period. Okay, so to solve this, a very simple principle. The interest earned over any year should equal to the account balance by the end of that year minus the account balance at the beginning of that year. Okay, or at the end of the previous year. It's the same thing. So to find the account balance by the end of the third year, this is what we do, right? So future value in year 3 equal to the present value times 1 plus the interest rate to the power of 3. I believe that you know how to solve this using financial calculator, so I'm not going to show that anymore. And the future value by the end of the second year equals to another number. Now the difference between those two is the increase in your money over the third year, which purely comes from the interest. So this is the interest you earned in year 3. Now the second half of the question, how much of it comes from simple interest? Now think about, if it's simple interest, that means you're only earning interest on the original principal, which is this $10,000. So If it's a simple interest, then the interest rate earned during the third year should equal to the original principal times 11%, which is 1,100. Okay. Now the difference between the total interest you earned, which is this number, and the simple interest should come from the interest that you earned on the interest that you earned during the previous period. Okay, that is the meaning of compounding, right? So that's the decomposition here. Now, the third question. If you are offered $100,000 today or $300,000 in 13 years, which one do you prefer? To solve this question, we need to do a little bit conversion, right? Because those two values are at different point in time, so we cannot directly compare them. So we can do two things. We can either move the money today to into the future, and calculate the future value of that money and compare the value by the end of the 13th year. Or the second thing we can do is to move the money in the future back to the present. In other words, we calculate the present value of this $300,000. Okay, and then we can compare the value today. Okay, so in the method 1, we compare the values in 13 years. So we need to calculate the future value of $100,000 today. That equals to $388,000. So from here we can see that the money today is actually worth more than the money in 13 years. Okay, so we're gonna prefer the money today. Now, using method 2, we can convert the money in the future back to the present. So the present value of the money in the future will equal to $77,000, which is less than the money today. Okay, so using the method 1, we have the same conclusion. We would prefer money today. Okay. So remember, those two methods will give you the same conclusion because the higher the present value, the higher the future value. The higher the future value, the higher the present value. So those two are increase with each other. Okay, so you won't have conflicting conclusion. Now, the next one. At what annual interest rate would $500 grow to this value in 12 years? And the interest is compounded every month. So to solve this one, there really has to be two steps. The first step, we need to calculate the interest rate per period, which is interest rate per month. And then we're going to convert the interest rate per month into interest rate per year. Okay. So interest rate per month, let me show you how to use financial calculator. So the 500, the N is 12 years, because now every period is a month. So over 12 years, there are 12 times 12, 144 months. That's the number of periods. I over Y will calculate it later. PV is 500. Payment is 0. Future value 1948. And remember, one of them, whenever you put present value and future value at the same time, one of them has to be negative. Okay, so I'm setting the future value to be negative. And then compute I over Y. So every period, the interest rate is 0.9488%. I'm just rounding it up. And then to calculate the interest rate per year, we simply use this multiply by 12. Okay. Now the next one. Now you can borrow money from a finance company at 12% compounded monthly, or from a bank at 13% compounded annually. Which alternative is more attractive to you? So at the first glance, we don't know directly which one is better for a borrower. Remember, as a borrower, you want to borrow at a lower interest rate. So because the first one is compounded monthly and second one is annually, so it's like comparing things at different unit. So what we have to do is to put everything into the same unit. So we can convert the first plan into its EAR. So the EAR of the first investment plan is 1 plus 12% divided by 12 to the power of 12. I'm sorry, it's a typo here. It should be to the power of 12. And then minus 1. Okay. Again, I want to show you how to use financial calculator. Okay. So you can go, let me just show you how to use the I conversion. Second, I over Y. And the nominal interest rate, remember to change everything. Okay. The nominal interest rate is 12%. And then you go down. Effective annual rate, we don't know yet. Compounding frequency is 12. And then go back to effective annual rate. So we want to compute it. Okay. All right. So if you compare the two investment plans, obviously we would prefer the first plan, which gives you a lower interest rate. Okay. All right. So that is all for all the comprehensive examples. During the following of the video, I'm gonna try to show you how to use Excel to solve those time value of money questions. Okay, if you're interested, you can continue watching. If you're not, you would be totally fine with just using the financial calculator. Okay, so now we can use Excel to solve time value of money questions. Here, I'm gonna just use a few examples to show you. Okay. All right. To solve in this example, okay. First, I'm gonna show you how to find future value. So in Excel, you just do equal FV, that's future value. And then you have to have the printed this. So now you see there are several hints. Those are the parameters that you need to input. So the rate is the interest rate. Okay, so it's 11%. Remember in Excel you have to add the percent sign. Okay, it's different from financial calculator. Number of periods is MEPER is number of periods, so it's 13. PMT is the payment. Okay, so we don't have that yet. PV is the present value. Okay, let me just do this. And the last one is the type. The type is asking you when does the cash flow happens. Okay, if you don't input anything, the default type is the at the end of each period. Okay, so we're gonna use this actually in the chapter 5. Okay, there's a difference between ordinary annuity and annuities due. Okay, so that is the future value. Again, in Excel, the future value is negative. It's the same logic as the financial calculator. Okay, if you put the present value as negative value, you're gonna have a positive future value. Now, to calculate the present value, you're gonna equal PV. Again, you're just gonna follow all those hints. The rate is 11%. Number of periods 13. Payment 0, future value is 300,000. Okay, we're gonna leave the type blank because we're just gonna use the default. So that's the PV. Okay, again, if you put this one negative, you're gonna have a positive PV. Okay, the next one, if you wanna compute the interest rate, okay, you're gonna equal rate. Okay. So number of periods is 12 times 12. Payment 0. PV 500. Future value negative 1,048. Okay. Let me just keep more number of decimals. To change the number of decimals, you're going to use this. So that's interest rate for a month. So now if you want to compute the interest rate per year, you use this one times 12. Okay, let me just change it again into percent. Okay, another thing sometimes you might need to calculate is number of periods. So N equal NPER. Okay, suppose in this example, we have the interest rate per, suppose we don't know the number of periods. Okay, instead we know interest rate. So what we do is we go 0.95%, payment 0, PV is 500, future value. Okay, so you see you need 140, around 144 periods, okay, which is exactly 12 years. Okay, now another thing you might want to compute sometimes is the EAR. Okay, so Excel has the function to calculate EAR as well. So to calculate EAR, you use EFF or effect. So you need to input the nominal rate and the number of periods per year. Okay, so nominal rate is 12%. Number of periods is 12. Okay, so you have, let me convert this to be percent. Okay, so you have 12.68%. Okay, now on the other hand, if you need to compute the nominal interest rate, you can just go nominal. The nominal interest rate, remember, it's the APR. Okay, so you can input the effective annual rate, number of decimal, number of periods. Okay, that gives you 12%. Okay, all right, so I hope you find this video helpful. All right, see you in the next video.